So I'm Matt King, I'm Professor of Polar Geodesy in the School of Land and Food at the University of Tasmania. Well, we're really trying to get to the bottom of how much Antarctica is contributing to sea level change. And one of the things that's going to influence how Antarctica changes in the future and how it actually is changing right now is this complex interaction between the ice that's sitting on the continent in Antarctica and the solid Earth that's below it. The Earth is a bit like memory foam. You put a weight on it and it holds its shape for a while, and then over a period of time it relaxes back to its original shape. And that's the thing that we face in terms of present day motion. You have to know what was sitting on the Earth many thousands of years ago in order to understand the shape it's in now, but also the rate of change of that shape. You can imagine if the solid Earth respawns and bounces up, and that's sort of dragging the ice out of the ocean water, which is actually the thing that's melting the ice sheet. So if we can get an understanding about how the solid Earth is moving and changing, then we can get a much better idea of how the ice sheet is behaving and how it's going to behave in the future. There's no doubt that one of the big uncertainties in the IPCC report and how we add up the various components to explain present day sea level change as well as future sea level change is, well, how much is East Antarctica in particular? A huge slice of Antarctica it's very high, it's very remote, it's very cold, and it's not very well studied. And one of the things we need to know is, well, what is it doing right now? And at the moment, the estimates suggest that it could be about imbalance, as in the amount of snowfall that falls on East Antarctica is balanced out by the amount of flow that goes out into the ocean. Other estimates suggest that it's growing substantially, as in the snowfall is far exceeding the amount of discharge. And so we have to be able to get to this to a better estimate of East Antarctica's contribution to sea level change, and that will make a major difference to our understanding of present day sea level and what drives present day sea level, but also the future sea level change as well. We're going to be doing some field work, particularly in the Antarctic Peninsula, where things are happening quite dramatically. We know the glaciers are melting quickly, and so that allows us to see things in very fast motion, because glaciers are melting right now and the Earth is responding right now, and if we measure that response by putting global positioning receivers on the Earth's surface there, and we know how much the ice has changed, then that is basically like a big stick probing the solid Earth there, and allowing us to go, well, with some modelling we can work out exactly what it's like down there, because you can't visit the Earth 300 kilometres down, and so you have to do it from remote measurements and through modelling of that system. So we're going to be trying to get down to the Antarctic Peninsula and really study this sort of thing in detail. The biggest challenge for us in this project is really getting the error bars down on the past history of the ice sheet. The estimates at the moment for all of Antarctica was that it contributed somewhere between 6 and 26 metres of sea level over the last 20,000 years. 6 to 26 metres is a lot of variation. So we need to be able to really narrow that down. Is it at the lower end or is it the upper end? And so through a combination of numerical modelling, of modelling the ice sheet, of forcing it with different behaviours around its edge in terms of the ocean temperature, snowfall, we hope to really be able to get a much better idea of exactly how it has changed.